Solve one-dimensional diffusion equation dou u by dou t equals alpha square dou square u by dou x square subject to condition u of 0 t equal u of pi t equals 0 and u of x0 equals pi x minus x square where x ranges from 0 to pi. Here we have L equals pi and temperature distribution at the initial position x equals 0 is given as 0. Similarly, temperature distribution at the end position x equals pi is also given as 0. From this condition, it is clear that along the end points of the rod, 0 temperature is maintained, and this is the initial temperature distribution. This is much similar to the case when we discussed in this question theta equals 0 at x equals 0 and theta equals 0 for x equals pi, which means that initial and end points of the rod are kept at 0 temperatures. Here we have to solve this one-dimensional diffusion equation whose Fourier series solution is obtained as u of xt equals summation n ranges from 1 to infinity bn sin nx e raised to negative alpha square n square t, where bn is the Fourier coefficient obtained as this expression. We have arrived at this expression by replacing L by pi. Now we will evaluate Fourier coefficient bn. We have bn equals 2 by pi integral 0 to pi x minus x square into sin nx dx when you replace f of x using the expression pi x minus x square. Here we will apply integration by parts for integration. First function into integral of second function. This function is differentiated here. This function is integrated and written here. Pi minus 2x is differentiated with respect to x and written here. This complete function is integrated and written here. Since negative 2 when differentiated will give 0, we will end the process here. We can rewrite this as this by considering negative into negative becoming positive here. When you give upper limit x equals pi for the first term, it becomes 0 because you will get pi square minus pi square making the first term 0. Similarly, when you give x equals pi in this term, you will have sin n pi which makes the second term 0. When you give x equals pi for the third term, it becomes minus 2 by n cube into minus 1 the whole raised to n because cos n pi equals minus 1 the whole raised to n. Now we will give the lower limit x equals 0. When you give lower limit x equals 0 here, we have pi 0 minus 0 square which gives 0 as the answer for the first term. Or you can consider x can be taken common from this bracket. When you give x equals 0, this complete term becomes 0. Here when you give x equals 0, we have sin 0 becoming 0. When you give x equals 0 here, we have cos 0 becoming 1 and thus we have this term obtained. Since we are using lower limit, we have a negative sign here and we obtain the term minus 2 by n cube. Thus we have bn equals 4 by n cube pi multiplied to 1 minus minus 1 the whole raised to n. And thus we have the general solution obtained as u of xt equals summation n ranges from 1 to infinity 4 by n cube pi 1 minus minus 1 the whole raised to n sin nx into e raised to negative alpha square n square t.